Hello, guys. Welcome. Thank you very much for joining us today. We are ready to begin our tech talk on turbine blade machining using turbo machinery in NX Cam, and that is a mouthful. So we are very happy that all of you guys were able to join us. Your questions will be answered live at the end, but feel free to go ahead and enter them into chat if they come up, if you would prefer. Our presenter today is Yahaya, who is in our Cincinnati office. And just a tiny bit about Yahaya. He has over 6 years experience in aero engine components, manufacturing industries, especially on CAM and CNC machining. So welcome, Yahaya. The Tech Talk is now yours.
Hello and welcome to Prolim's Tech Talk. Thanks for joining. Today I'm going to walk you through the turbo machinery capabilities in NX CAM. This area of NX is built specifically for handling complex parts like blisks, impellers, and turbine blades. We'll explore how NX CAM helps us to simplify the workflow and automate the repetitive task and generate better quality toolpaths for this challenging geometries. So let's get started and take a closer look at turbo machinery in NXCAM. So here I do have a Blisk part open in the NX. So I'll define a multi-blade geometry. It is available under the create geometry icon. So inside the geometry subtype, we'll be selecting the mill multi-blade, and with this multi-blade geometry, we just have to define um, ones for all the hub, shroud, blade, and all other features, and then we can create operations based upon that, and it will take all the information that we are defining over here, and then we don't need to define it again and again. While defining the blade geometries, it's always a good practice to follow the sequential format, and you have to follow the same method for the blade blend surfaces as well. You have to choose in the same sequence like you did for the blade surfaces. But whereas in the splitter surfaces, when we are specifying those surfaces, uh, it shows us the options for the wall and the blend faces together inside a single dialog box. So again, I mean, the sequence should be followed for the both blade and the blend surfaces. So once we have all the features defined, and depending on the instances of your blades, you need to specify the total numbers. In my case, it is total 6 numbers, and the axis of rotation should always be in the way how your impeller or a blisk is created. So always the hub should rotate around the axis of the rotation. So that's the main catch over here. So once we have defined our geometry, let's go ahead and create a roughing operation. So inside the operation subtype, under the mill multi-blade, you'll be able to find all the impeller and blisk related operations. Um, Again, depending on your geometry, whether it's impeller or a blisk, you can choose the operation subtypes over here. In our case, we're going to choose the impeller rough. And inside the operation, we have a few important options that we need to take a look at. So before we do that, let's define our distance for the depth of cut and the distance for the step over as well. I'm going to put some random numbers over here. And under the geometry tab, we'll specify the stock value. So I'll be giving some stock for the blade, for the hub, and also my check geometry. And coming to the axis and avoidance, here we have some few important options to see. Inside the tool axis, we will be using the automatic option, because this is the best suitable option for the most of the cases. Depending on the complexity of the blades, we can use interpolate vector. I mean, you can choose your individual vectors along the blade. So this is automatic, will work in the most cases. And the clearance angle, I'm going to leave the rest as it is. And for the tool axis smoothing, if it is a finishing operation, then we can increase the percentage for the tool axis, but for the roughing, I think the 25% would work. And coming to the strategy tab, so the blade edge over here, we have three different options. So these are basically the extensions near the edges of the blade. So when you say no curling, it tries to not to go beyond this curl over here. And if you say along the blade direction, it tries to move along this direction based upon the tangential extension what you have specified. And for the along part axis option, it will go all the way to the hub that we have defined over here. And the trailing edge, usually it is as same as the leading edge. So coming to the reduced tool load when embedded, so this option is basically allows you to define a roughing method at each cut level. So when you say none, so it's gonna rough the machine areas between the blades with no additional motion. But when you choose the multiple depth on slotting, that means it lets you create additional roughing passes where the cutter engagement has 180-degree or more than that. And when you say two passes alternating depths, it lets you create additional roughing passes directly on the blade surfaces or like alternating between them. And when you choose the slotting array, is it lets you create additional roughing passes first centered between and then directly on the blade surfaces, what we have defined over here. So let's choose the multiple depth slots, and we can specify the three numbers over here. And coming to the non-cutting moves, this is not too much of mandatory, but based upon your results, based upon your toolpath results, you can alter this. But I'm going to turn off the smoothing engagement moves here, and I'll give a less part safe clearance. So let's go ahead and generate. Now we have our operation generated. As you can see that we have seen in the operation dialog box, according to the blade direction, we have specified the value. So it kind of stopped over there and started taking the next step. So we have our roughing operation ready. So let's go ahead and take a look at the other available options. So next thing, we're gonna take a look at the blade finish. So inside the impeller blade finish operation, we have the geometry to finish, whether do we need to finish the blade or the splitter. So for now, we're going to select the blade. And for the size to cut, it's actually depends on the geometry of your blisk or impeller. So when it says left, right, and the leading edge, so at the trailing edge, we basically has a flat circle over here. So that's the reason we are choosing left, right, and the leading edge. And I'm going to specify some step over distances over here. And a cut pattern, we do have zig, and you can even choose the climb and conventional. And let's take a look at the geometry. So that looks good over here. Let's go ahead to the axis and avoidance. So for the tool axis, again we're going to use the same automatic, but for the tool axis smoothing, like I mentioned, we'll be using somewhere around 80 to 60. So let's keep it to 60 percentage. And coming to the smoothing method, again, if you want a different vectors along the blade, you can also choose that. But if you want NX to choose the vectors, then you can specify the spherical angles. It will choose the vectors depending on your blade geometry. So let's take a look at other options. Let's go ahead and take a look at the strategy. We'll set this back to the along blade direction, and we'll give a distance of 5 mm. And let's go ahead and generate the toolpath. So we have our rough finishing operation generated. Let's take a look at that. So since we have our finishing operation generated, let's go ahead and do the finishing toolpaths for our hub and also for the splitter blade as well. So let's start with the splitter finishing. For the splitter finish, we can use the blade finish as well, and then we have to only specify the geometry to finish as a splitter. And then for this we can also change the sides to cut to all sides and see how does it behaves. Specify some distance over here, and the cut pattern we'll change that to helical, and let's hit generate to this. Alright, so our splitter finish operation has been generated. So this is the difference between all sides and the left, right, and the leading edge. So if you want, we can go ahead and also change this to all sides to have the cleaner toolpath. Okay, so now it looks good. Both the finishing operations has the same strategies. Alright, now let's move on to finishing the hub geometry. So there is a toolpath for the impeller hub finish as well. So for the cut patterns inside the hub finish, we can choose either zig or zigzag with lifts. And let me specify some step over distance. So let's go to our axis and avoidance. Let's reduce the clearances for our holder. And let's take a look at the strategy. Again, we can specify this as along blade direction. Let's give a radial extension of 50%. And everything looks good to me. Let's go ahead and generate this. So the radial extension, what we have specified is basically merging the two different surfaces over here. So it merges at the hub area with the 50% of the direction. Before we have specified for other operations only the tangentials. So by this you can avoid any steps over here. All right, now since we have our hub finish operation generated, let's go ahead and create the blend finishing operations. Okay, so here inside the blend finish operation, you can we have the same options like we saw in the blade finish, whether we need to finish the blade blend or the splitter blend. So for the sides to cut, usually if you don't want the blended corners over here, you can choose the left, right and leading edge. But if that is okay for you, then you can choose all sides, so it's kind of create a circular path over here. We can change the cut pattern to helical. So for the drive method, the lower edge, the lower blend edge, it actually defines the drive path from the edge blend geometry. But if you use the reference tool, it kind of create additional passes like the drive path from the reference tool contact points with the part geometry, and you can specify the reference tool diameter as well. So we'll go with the lower edge blend, and we'll specify the cutovers as an offsets or stepovers. We'll say 2 stepovers on the hub and the 4 stepovers on the blade. Let's change our stepover distance to 0.2 mm, and let's go ahead and generate the toolpath. Depending on the material that has been left on the edge blends, we can play with the values of these stepovers on the or on the number of hub or number on blade. So we have to apply the same method for the splitter blade as well. So why don't we just copy this operation and just change the settings for the geometry to finish. So I'm going to change only the option for the splitter one blend, and then I hit generate. Okay, so our toolpath has been generated. So since we have all our operations generated, let's go ahead and take a look at the simulation. So if you notice in the simulation or in the NC output, as we have only created operations for one singular blade and one singular splitter blade, but in the NC output it kind of creates all the instances, and it tries to machine whole impeller. So this is because our post is set up in a way that you don't need to create multiple instances of the operations inside the NX, but you just have to specify how many blades would be in your impeller, and you just need to create one single tool path for blade finish, hub finish, and also as well as blend finish, and the post will take care of all other instances. So we can develop a post in a similar way for you if you are interested, or like if you're using turbo machinery in your shop, so that you can save a lot of time by no by avoiding creation of all other instances of these blades. So this is our total roughing operation, and I'm gonna skip this until our blade finish operations as well. And so now here at this stage we have all our main blades finished. So let's go ahead and skip this until the splitter finishing. So now our splitters operation has also been skipped until there. So let's go ahead with the hub finishing. And here is our hub finish as well. So this is how our impeller looks like after getting finished. So I'll stop over here, and so that's all what I've got to show you for the turbo machinery module. I hope you like this tech talk and you got something out of it. Uh, and thank you so much for attending again. If you would have any questions, please feel free to ask.